Hey guys, in this video I'm going to show you how to use the chain rule to find the derivative of a function, and I'm going to walk you through two tricky examples. Starting with part A, we've got y is equal to the square root of 6x minus 5 divided by 6x minus 5. Now since we're asked to use the chain rule specifically, start by writing its formula down, which is dy dx is equal to dy du times du dx. Looking at the function, we've got a square root sign in the numerator. Now, whenever you see a square root sign and you have to derive the function, you should always rewrite it in exponential form. And so doing this, we can write y is equal to 6x minus 5 raised to the power of a half divided by 6x minus 5. Now notice that we've got 6x minus 5 raised to the power of a half in the numerator, and then we've got 6x minus 5 raised to the power of 1 in the denominator. And so what we're going to do is treat this as the base. And so applying the index laws, we know that if we have the same base and we're dividing, we subtract the powers. And so a half minus 1 is going to equal minus a half. And so this is equivalent to 6x minus 5 raised to the power of minus a half. Now that we have it in this form, what we do is we let u equal whatever's inside the brackets. And so we let u equal 6x minus 5. Deriving this, we're going to get du dx, and this is going to be 6. Then we need to write y as a function of u. And so y is going to equal u raised to the power of minus a half. And so dy du is going to be minus a half times u raised to the power of minus 1.5, which is the same as minus 3 on 2. Now that we have dy du and du dx, we sub this into the formula to work out the derivative. And so dy dx is going to be dy du, which is minus a half, times u raised to the power of minus 3 on 2 times du dx, which is 6. Simplifying this is going to be minus 3 times u raised to the power of minus 3 on 2. And now we sub in u back in as a function of x, and so this is going to be minus 3 times 6x minus 5 raised to the power of minus 3 on 2. Now generally, whenever you're answering a derivative question, you want to have positive powers. And so rewriting this to have a positive power, this is equivalent to minus 3 over 6x minus 5 raised to the power of 3 on 2. Part B. F of x equals x squared plus 2 raised to the power of 2 divided by the square root of x squared plus 2. Again, notice that we've got a square root sign. And so what you want to do is rewrite this function in exponential form. And so we can write f of x in equivalent form as y is equal to x squared plus 2 all squared divided by x squared plus 2 raised to the power of a half. Now we've got x squared plus 2 in the numerator and in the denominator. And so this is going to become the base, and using the index laws, we can subtract the powers. And so 2 minus a half is going to be 1.5. And so this is equivalent to x squared plus 2 raised to the power of 1.5, which is the same as 3 on 2. From here, we let u equal what's inside the brackets. And so this is going to be x squared plus 2. And so deriving this, du dx is going to be 2x. And writing y as a function of u, this is going to be u raised to the power of 3 on 2. And so dy du is going to be 3 on 2 times u raised to the power of a half. Now that we have dy du and du dx, we sub this into the formula to work out the derivative. And so dy dx is going to be dy du, which is 3 on 2 times u to the power of a half times du dx, which is 2x. The 2's will cancel out, and so this is going to be 3x times u raised to the power of a half. And now we just replace u back as a function of x, and so this is going to be 3x times x squared plus 2 raised to the power of a half. And so therefore f dash of x can be written as 3x times the square root of x squared plus 2. And that's it for this video. I hope you found it helpful, and if you did, then click on the like button or comment below and let me know. And don't forget to subscribe to this channel. Good luck, and I'll see you guys in the next video.